Algebra 2, Unit 3 Study Guide, Polynomials, Concept 13. So number 1, what makes an equation a polynomial? You're looking for two things. The first thing you're looking for is that you have real number coefficients, and the second thing you're looking for is whole number exponents. So real number coefficients and whole number exponents. So an example of a polynomial that has both of those criteria could be f of x equals negative 2x squared plus 1/3 x. 1/3 is a real number. A non-example might be, let's do an exponent that isn't a whole number, so 3x to the negative third power. And then a coefficient that's not a real number would have an imaginary unit, an I, by it. So this is not a polynomial, and this one is. Number 2, in standard form, you just want to make sure that the greatest exponent term is first. So you just scan your polynomial and notice that x to the 5th is your biggest power. And then you just rearrange those terms and work your way down. So we have x to the 4th, and then 9x squared, and then finally 4. Now on number 3, we want to find the leading coefficient and degree of that polynomial. But the first thing that we need to do is to put it in standard form. So we scan, and 9 is our biggest exponent, so our first term would be negative 3x to the 9th. Our second one is x to the 8th. And then our third term will be positive 2x squared minus 15. So our degree is the highest exponent, so we have polynomial of degree 9. And then the leading coefficient is the number that's in front of the term with the highest exponent, and so that would be negative 3. On number 4, you want to fill in the table from your notes, and this comes from Concept 13, and I have the table here so you can see it. In particular, you're looking at these 3 columns. So here's the degree, and then the type, and then finally an example. So you can either use f of x or you can use y. Review this table for the quiz so you can identify the degree of a polynomial, that you can state its type, and that you're able to identify an example. At number 5, we want to evaluate the polynomial when x equals negative 2. So here I've used direct substitution. That's when you plug in the number. You can use your calculator and then find out what that function equals when you plug in negative 2. You should get negative 36. On number 5, we're going to evaluate using synthetic substitution. So I've set up my synthetic substitution. I take the exponents and I list them in order, and I just make sure that I'm not missing any terms here. If I am, then I need to put a 0 placeholder. Remember, we start by bringing down that first term. Then you're going to multiply on the diagonal and then add on the vertical. So multiply on the diagonal and add on the vertical, and then multiply on the diagonal and add on the vertical. And when we're evaluating, we're interested in the last number, that is the remainder. So we can write this as g of negative 3 equals 275. This concludes the problems for Concept 13. For videos over Concept 14, just go to the next video on the playlist. For answers on the problems from Concept 14.